Hey everyone, my name is Dr. Dan Grissom, and in this video tutorial we are going to take a look at the scanner class. Now the scanner class is really one of the basics. It's typically one of the first things I do in any Hello World program in Java. So what is the scanner? The scanner essentially allows you to read things from the user. Well, specifically it allows you to read plain text. Typically in our Hello World programs, we're reading plain text from the console. The console is where I basically print out my Hello World. So if I did a basic program here and I said Hello World, and then I run this, you'll see Hello World is going to be printed out onto my console right here. So typically in your Hello World, you're just printing out to the console, but we can also read from that console as well. So the scanner is used for that, and the scanner is also used for reading plain text from a variety of sources, namely the file system. So you can actually read plain text from files as well, which is the other top use case for the scanner. So anytime you want to read plain text, meaning strings or numbers or even any of the basic Boolean, basic primitive data types in Java, such as Booleans and longs and doubles, scanner is a really great option. So let's take a look specifically about what we are going to do in this particular example. So we're going to take a look at the different various constructors for the scanner class. You'll see there's a number of them. You can read in from a file, InputStream, path, readable, ReadableByteChannel, as well as a string. In short, this is really just reading in from input streams such as the console, files, as well as a string. Those are the three kind of higher level use cases. These are just kind of more generic classes that can be read from. We're going to take a look at a number of different methods, specifically the has, next, and next family of methods, as well as two specific utility methods that are really useful, especially when you're doing reading in from a file. So specifically the close and the use delimiter methods. So just as a quick reminder before we jump in, the scanner is really the class that you want to use anytime you want to read in something from the user, either from the console or from a file. It's a great option if what you're reading in is plain text, meaning something that a human could actually write with the keyboard and read with their eyes and kind of get some comprehension from that. Okay. So let's go ahead and look at our program. I have some general kind of bare bones of what we're going to do here. You'll see there's three general scanner examples that we're going to go through. The first one is going to these are going to kind of broken off into the various constructors that we can see. The first one is going to be an input stream where we're actually reading in from the system.input. Okay, the second one we're going to test out reading from a file as well as a readable and a path. So those are just different various constructors. And then the last scanner example, we're going to read in from another file, but we're going to do so using the InputStream, ReadableByteChannel constructors, and then we're also going to create a scanner which scans a string. So we'll get to see just how versatile the scanner class really is. So let's go ahead and get started. The first thing I'm going to do is kind of what I typically do in a Hello World, which is create a scanner which scans that system.input over here. So let's go ahead and create a scanner. I like to call it scan. So scanner scan is equal to new scanner. And then in that constructor parameter, I'm going to pass in system.in. Okay, so make sure that you import scanner from the java.util class. Okay, so you can see my program is going to open a scanner. It's going to read data from the user until that user types a -1 over in the console. And then we're going to close the scanner. So I'll go ahead and just close it right now so I don't forget to do this later. Anytime you open a scanner, it's always a good idea to close it. Now I will say with if you're scanning the system.in, the console over here, this is one I typically don't close in practice because you almost always want to be interacting with your user from the beginning to the end of your program. So it's usually safe to leave that open. Once your program terminates, it'll automatically close that scanner stream to the system.input. However, once you start opening files using the scanner and kind of connecting to files using the scanner, it tends to be a better idea and a little bit more critical to the actual functionality of your program to make sure that you are closing those those file scanners. So it's just a good practice. We'll go ahead and close the scanner here as well. Okay, so let's read data from the user until the user types in -1. So what I'm going to do is I'm just going to start off by making a while loop, and this is going to be what looks to be bad practice at first, just while true, but I'm going to have a break statement in here. And essentially what I'm going to do is I'm just going to keep prompting my user. So I'm going to say something like this. I'll say, please enter some data, and hit enter. And then I'll say -1 to quit. Okay, so we've got this program. It's just going to repeatedly ask them to enter some data. You'll see I still have an error in my program because the Java thinks that this is unreachable code, and it is because I have this infinite for loop at this point. So let's go ahead and actually work with our scanner a little bit. Okay, so what I'm going to do now is I'm basically going to check the next piece of data on the console, which is also the system.in. So I'm going to use those two terms, console and system.in, pretty interchangeably. Okay, so what I can do is I can say if scan.has next int. Okay, so let's go ahead and just look for a number out there for starters. That's essentially what this is doing. It's saying, all right, this scanner, which is scanning the system.input, does it have an integer next? Is the next piece of information out there an integer? Okay, now at this point there's nothing out there. The hello world even I deleted, right? So there's really nothing out there. So what's going to happen is I'm gonna write a little bit more code because it'll be easier to explain what happens if I kind of continue this example just a little bit more. Okay, so what I'm going to do is if it has an integer out there, I'm going to say int data is equal to scan.nextInt. Okay, basically, hey, if it has an integer next, then go ahead and grab that next integer. And then let's go ahead and print it out to the screen. So we'll do a system.out.printf. And here I'll just do a tab. It's going to be a formatted string, so we'll do a tab with a %s is an integer. And we'll do a few new lines there. And then I will pass in data there. Okay, now you can see I still have this infinite for loop. So what I want to do is at this point, I have an integer. And so I want to basically break out of the loop if user enters -1. So if data is equal to -1, then I'll go ahead and just break. Okay, so what we should see now is I can enter numbers 5, 44, -1. -1 is an integer, but that also causes me to break out of that while loop and then close the scanner and in my program. Okay, now what happens if there is a different type of data that someone, so far what I did is I just said, all right, has next integer. Okay, so if I typed in 55, cool, no problem, it works. What if I type in something like 5, the number or the word 5? What we will see is actually we just get an error. Okay, it's going to do an input mismatch error. Should be an exception. Looks like it's bugging out my input just a little bit. But as you can imagine, right, is I'm trying to read in this this integer. I'm trying to read in an integer, but I typed in a string. Okay, so we have to update our code a little bit so that we can actually expect different types of data. So what I'm going to do is I'm going to show you that this has next int, and the next int is really a family of methods. These has next and next. So what we can also do is we can say something like this: else if scan.hasNextLong. Okay, so as you may or may not know, integers have a range that they can represent. So an integer in Java, for instance, is a 32-bit number. So it can represent values from roughly about -2 billion to +2 billion. So with that said, I can also then check else if scan.hasNextLong. Okay, and then here I'm basically going to copy these two lines. And this time I'm going to say long data scan.nextLong. Okay, and then this data is a long. So let's go ahead now and run this. So if I do something like 4 billion, you'll see that 4 billion is a long. But if I give it something like 40,000, 40,000 is an integer. Okay, now let's go ahead and format this just a little bit different so you can actually read that properly. So this %s is going to format whatever I give it, just using its generic formatting rules. So I actually want to put some commas in here. So the way that I can do that is instead of %s, I can say %d, and then you'll really be able to see. Now when I say something like 4 billion, you can see very clearly that's 4 billion. Now if I do 2 billion, okay, 2 billion is an integer, no problem, but 4 billion is a long. It exceeds the range of that integer. Okay, so let's go ahead and extend this example out a little bit more. We'll go ahead and read in a few new data types. So I'm just going to copy this else if. Okay, and then for the next one, we're going to try and see if there is a double. Okay, so maybe they entered in a value that actually has some decimal points. So we say scan.hasNext double, scan.next double, and I need to save that into a double data type. And then I'll go ahead and just go back to my %s. I'll say is a double. Okay, and then I'll copy this one. Okay, and then for the next one, I'm going to say has next boolean, and then next boolean. And then make sure you save that data as a boolean data type. All right, so now when we run this, it's going to be a lot more flexible. Okay, so I can read in a number of different primitive data types. I can read in 45. I can read in some bigger number as an integer, some really big number as a long, some number with decimal points as a double. I can read in true. You can see that I can actually type it in as all caps true. You can see it pretty much ignores the case sensitivity. It figures out that particular string matches the false or true Boolean data type. And then finally, though, what if I type in a word, right? That actually wasn't in our data type. You can see I'm just getting like an exception there. Okay, so the last thing I want to do here is I'll say else if scan, well, this is really an else type of situation. Okay, what I'm going to do now is I'm going to read in anything else, right? If it's not an integer or a long or a double or a boolean, everything else can be represented as a string. So I'm going to say string data is equal to scan.next. Okay, now you'll see there's a number of different nexts out here. We've looked through some of them, right? Next double, next. Let me actually get rid of the string data equals so you can really see this very nicely in the autosuggest. All right, if I do next, you can see all the different options. We've used a sum of these, the next long, next double, next boolean, but you'll see there's a number of options that we're just not going to go into, but because they're not very common. But if you do find yourself wanting to read in things like a big decimal or a big integer or maybe a byte data type, you can do that. A float, a next line we're going to use a little bit later, but next short is another data type. So you can see there's a lot of different options there to use. Same for the has next. We looked at has next long, has next double, and so on and so forth. But there's the same, right? Has next big decimal, has next big integer, has next short, has next byte, and so on and so forth. But has next will always work. Okay, so has next integer, has next long are only going to work if they happen to type in numbers, right? If you just say scan.next, that's always going to take whatever characters are out there and interpret them as a string. So I can say string data is equal to scan.next. And then I'll go ahead and I'll just print that out. I'll say %s is a string, right? So everything else can be represented as a string. So I can do a number, a boolean, a double, but then anything else I type in is just going to be a string, right? I can type in all kinds of weird characters, still a string, right? If I do a big decimal number and then put a character at the end for some reason, it's a string. So that's one way that we can basically kind of shore up this if-else statement to guarantee that it's not going to end in an exception of some sort. Okay. Now, one thing I had not necessarily pointed out earlier in my example here was I am actually doing all of this in a try catch. Okay, so you can see try, and then all the way down here you'll see catch, and then with the exception. Okay, so this is actually why nothing was printing out earlier when I got that particular error. If I wanted, I could actually pull all this stuff out. Just do it to show you. Okay, and then if I comment out my else statement here and run this, okay, you will see that we will get our exception there. Actually, the while loop's making that a little bit difficult to display, so what we can do is right when we create the scanner, if we just say something like scan.nextInt, or I'm sorry, scan.nextInt, and we just try to read the next integer. So this time when we play it, instead of typing in something like 4, if we type in FOUR, you'll see this input mismatch exception. So that's very typical. It's very good to see that exception. I want you to see that because you will for sure run into this input mismatch exception. And essentially what that means is, hey, I'm trying to read in an integer and you typed in like a string. Or hey, I'm trying to read in a double and you typed in an integer or something like that. Although that integer can be saved into a double, so that wouldn't generate an input mismatch exception. But nevertheless, I did want to just show you this exception coming up because you'll oftentimes see that if you just make a mistake, you think you're reading in a double next, but in reality it was a boolean or something like that. Okay, so I'll go ahead and I will put this code back inside our try. And the reason that this code is in a try is not because of what we've been working on right now. Whenever you're reading in from the user, via the system.input, you don't really need to surround it with a try catch. That's more for the reading from the file, what we'll see later. Specifically, for the most part, if a file doesn't actually exist, then it's going to generate an exception. Okay, so let's go ahead and run this one more time. Okay, so let's go ahead and close our scanner, move that code down. Perfect. Okay, so now we have this nice little bit of code here that's successfully scanning the input. So I can type in a number, a really long number, a number with decimal points, which is a double, a boolean, and then really just any other string in there, and it will read that. So then I can do a -1 to basically get out of that for loop, or out of that while loop. Okay, so that's the scanner. That's probably the number one use case of what you'll use the scanner for, is just basically being able to get input from your user. And you're almost always going to read it into one of these data types. Typically it's either an integer you're reading in, or a double, or a string. Those are by far the three most common use cases I have, reading in numbers via integers and doubles, or just reading in string data from the user. Okay, but another thing that you might want to do is actually read from a file. Okay, so if you look at my package explorer, my project explorer over here, I have my code, this scanner demo.java file, but I also have two other input files. One is just input.txt and flights.txt, and you can see these both just live right there beside my source folder. And if I look at the contents of these files, you'll see input.txt is just a standard text file. Hello, my name is Dan. I'm having a very good day, and I hope that you are too. Okay, so almost like a book, I just kind of have this natural break at the end of the line where I'm going to kind of flow over to the next line. Flights, you'll see, is a little bit more data-centric. Okay, so flights is going to have some information for a source, a destination, and then a price. We'll get to flights.txt in a little bit. We're going to focus on input.txt here so that I can show you how to actually open a file and use the scanner to read in all these different words. So let's get started with our next example where we're going to create a new scanner. So here we're going to open a scanner which scans that input.txt file. We're going to read each word in from the file into an array list. Then we're going to iterate through the array list and print the words from the file. That's basically just to demonstrate that we did in fact read all this information from the file. And then we're going to go ahead and close the file scanner. Okay, so let's get started here. All right, so the first thing I'm going to do is create a scanner, another one, say scanner, and then I'm just going to call this one fscan for file scan. This equals new scanner, and this is typically, I would say, one of the easiest ways to read in from a file. Just on the scanner, pass in a new file, and then in there you can just type in as a string the input file name, so input.txt, and then do a semicolon. Make sure that you import file from java.io. Okay, and this is again reading in from a file. All right, you'll see if I hover over scanner, what it sees here is a file. Earlier, when we called the scanner constructor, it was looking for an input stream. Okay, so what I've done now is this is just this little line right here, new file, created a new Java file data structure and connected to the input.txt. All right, but that's really just a bunch of bits and bytes, zeros and ones as far as the file is concerned. The scanner, what the scanner does is it basically wraps itself around that file and tries to interpret those zeros and ones as things like booleans and doubles and longs and ints and strings and so on and so forth. Okay, so let's go ahead now and actually read through each word in the file. This is very, very easy. Basically what I'm going to do is I'm going to start off by creating just an empty array list. So I'll say array list, and this array list is going to have a bunch of strings in it, just a string for each word. And say file words is equal to new array list string open close parentheses. Do make sure that you import array list from java.util. Okay, and then now this is really cool. So what I can do is I'm just literally going to open up this file and just read one word at a time. Okay, so what I can do is I can say while fscan, so this scanner, right, is looking and just looking at all the zeros and ones in this file, and it's determining what they are. Okay, so what I can do is I can say fscan.hasNext. And what this is basically doing is looking through that file and saying, hey, is there one more word in there? Is there one more string in there? Okay, now when it says has next, you may have caught on to this earlier, has double, has next boolean. What it's actually looking for is it looks for characters separated by white space. Okay, let me actually, to demonstrate that, I can go back to my original example. Now I had done something like this. I had done like 4 and then 4.5, and it works as you would expect. But what I can also do is I can type in 4 space 4.5. Okay, and what you actually see here is it grabbed that 4 as an integer and then it printed out please enter some data, and it didn't actually allow me to type something in. It just went ahead and grabbed that 4.5 and said, oh, that's a double. Okay, so I can do similarly true, some big number, and then Dan. And you'll see it pulls out true as a boolean, 45 billion or whatever that is, trillion is a long, Dan is a string. Okay, so one thing I want to point out here is this these methods has next and next long, they actually the way that we had done this program so far, it made it look like I always just sit there and it's like this method that causes my program to wait. Okay, and in some sense it does. This method right here, the next long, for instance, the has next, these are called blocking methods. Okay, what that means is it's going to block the execution of my code. Okay, so this has next long, or this has next int, basically looks out there and it just doesn't see anything. Like if I just run this program, okay, I mean, let me actually run this through the debugger. You should see this a little bit more clearly. So I'll set the debug there, and then I'll actually go ahead and to the next line. So I'll hit F6, and you'll see the view is a little bit off here, but you'll see that the code is actually waiting. Okay, I can actually type in something up here, so like 66 for instance. And as soon as I hit enter, you'll see the code has not progressed past this has next integer. So when I hit enter, you'll see that it actually then goes and says, oh, right, that was an integer. It wasn't, right? So it goes ahead and tries to read it in now. Likewise, if I run this one more time, and this time I type in, I'll go ahead and try to run this line of code has next int, you'll see it just kind of pauses right there. This time I type in something like true. Okay, you'll see what it does is it basically now it says, all right, now I have something to look at. I have this word true. Well, true is not an integer, so I'm going to go ahead and try to see if it's a long. Well, true is not a long. It's not a double. Oh, true is a Boolean. And then it goes ahead and it reads that Boolean, that true, off of the input stream. Okay? Now, what's a little bit different here is if I actually type in 66 space true. Okay, and then I hit enter. Okay, well, I meant to run that in the debugger. Let's do this one more time. So I'll run that has next int, and then I'll do 66 space true. Okay, so what happens now is it looks and it sees 66 and it says, cool. What I didn't explicitly say that maybe you picked up on is it sees this natural delimiter or separating character or token as white space. So it's basically looking for all the characters it can find until it sees a white space. So it grabs 66 and says, all right, is 66 an integer? Yes, it is, right? So goes ahead and reads in 66, and now we are left with just the word true out there. So I go and I basically go back through that while loop, and it says, please enter some data again. Now it actually is examining true because true is still sitting out there on the console. So I'll go ahead and I'll run that has next int. Nope. Next long. Nope. Is true a double? Nope. Is true a Boolean? And finally it says, oh, true is a Boolean. So it goes ahead and it reads in that Boolean into data and it prints it out, right? And then it comes back again one more time and it says, all right, now let's go and try and read the next thing. Is the next thing an integer? But when it looks out there this time, there's nothing out there, right? During my first two iterations of this while loop, I read in the 66 and the true. So now this is the point where this has next method is going to block the execution of my code. Okay, so let's go back to the example we were working on. Okay, so when I say while the file has next, what I'm doing is I'm basically just looking through and I'm saying, hey, as long as you see one more word with some kind of white space after it, then let's keep going through that through this file. So basically I'm iterating through this file one word at a time. And all I'm going to do in this file is, as I keep saying has next, I'm just going to say file words dot add, and then I'll say file scan dot next. Okay, so this is exactly the scan dot next that we use up here. It's just going to grab the next string, which in this case are naturally my words, right? All the white space separated values in here. Okay, so once I have iterated through that entire file, I am then going to iterate through my array list. So I'm just going to say, I already have a kind of a print statement here. Input.txt has the following words. And then I'm just going to say for int I equals 0, I'm going to iterate through this array list of words. I is less than file words dot size I++. And I'm going to do a system.out.printf, And in my formatted string, I'm going to start off with a tab. Now let's say %s for basically just the number, word number 1, word number 2, and so on and so forth. And then %s where I'll actually print a new word and then a new line character. So that first %s is going to be I plus 1. And then that second %s formatter is going to be file words.get I. So all I'm doing here is I'm iterating through the array list, and the array list should just have every single word in that input.txt file. Okay, and then the last thing I want to do, as always, I want to close my scanner. Okay, so I'm just going to give a -1 for this first example, and then we'll see very clearly input.txt has the following words. Hello, my name is Dan. I am having a very good day, and I hope that you are too. Okay, so you can see it does not keep any of the spaces. I had a space in between the number and the word, and then you can see as I highlight after it, there are not any spaces in most of these. Actually, I will say this one, what you're seeing is just the new line character. Okay, but yeah, so that's actually just pulling out just the characters right there. Okay, so what we saw here was this has next. Okay, we didn't explicitly use that up here, but if I just want to read in a bunch of words, this has next allows me to know, hey, there's one more word, hey, there's one more word, there's one more word, and so on and so forth. Okay. All right, so sorry, there wasn't a new line character right there. It's just a kind of a figment of the Eclipse, the way it's displaying stuff here for some reason. This is the new line in the console output, not necessarily the new line that was read in. There was no new line that was read in from here because the scanner essentially sees all white spaces the same. So whether it's a space or a new line character or a tab, it sees that as a separating value. Okay, so in this this constructor here, we basically showed that a scanner can open up a new file. All right, but what I want to show now is not only can you open up a new file as a parameter to the scanner, but almost all of our scanners have two options. All of our scanner constructors can take a second parameter, and that second parameter is actually a character data set. So I can say something like this: standard char sets dot, and then I can pick from one of these character sets. So maybe do US ASCII, and then it's actually expecting a name. So I'm sorry, a string. So if I actually do the name method, that will return a string. So you can see here, right, the scanner is now looking for a character set name. So essentially what we'll see is when I run this, I can, if I pass something like US ASCII, it's going to read in just fine. I can try another data set such as UTF-8. So UTF-8 and ASCII are actually compatible with one another. So you'll see this shouldn't cause any issues. However, if I try something like UTF-16, what we will see in this case is UTF-16 is actually not compatible with UTF-8 or ASCII as far as we are concerned with these kind of standard English alphabet characters. So you'll see this time input.txt has the following words. It basically is trying to read stuff in, and it just doesn't recognize, doesn't see that those natural words like it does with the other character sets. So all that to say, you can, if you're doing something interesting where you're trying to read in different various languages, that you can kind of hard code what language it is expecting. That said, I've not really had to use that in practice because by default the scanner will pretty much figure out what character set your file system is working with, and it will pick that by default. Okay, so let's continue on. What I also want to show here is just a few more of the scanners, scanner constructors. Okay, so I'm going to get rid of this character set stuff. You can always add that as another option. But the next one I want to show, a lot of times people will read in from files using a buffered reader. So we can scan a buffered reader as well. So you can say new scanner and then pass in a new buffered reader. And to create that buffered reader, I'm going to pass in a new file reader, in this case, input.txt. Okay, so I will need to import the file reader from java.io and the buffered reader from java.io. But what you will see is if you run this, we're going to get the same results. We are successfully reading in from that file. Okay, so this is, you'll see the scanner constructor that we're using this time is reading a readable. Okay, so by inheritance, buffered reader is a readable. Okay, or rather I should say that the readable is actually an interface, so the buffered reader implements the reader interface. Okay, so there's one more scanner that's kind of easy to just plug and play right here, scanner constructor. And again, you can create your files any way that you want. I know that oftentimes I find in Java everyone kind of has their own preference, so I just want to show you how you would use the scanner to read in from a variety of input sources. So the other one that I might use is the path object. So I can say paths.get and then just pass in input.txt right here. And again, this is the path. And you'll see the scanner constructor here, again, is just taking in that path as its data type. So now when I play this one more time, you'll see again, you'll see it's working as expected. Okay, so with this scanner, we just showed the 3 different constructors that take in a file, a readable, and a path, as well as that we can modify all. I didn't show that you can modify these other constructors, but you can. They basically all have a second version that takes in that second property, which is just the character data set. But like I mentioned earlier, typically you're not going to have to manually set that character set. You can pretty much just pass in that one parameter, and it's every time I've ever used this scanner, it figures out the right constructor or the right character set. Okay, so let's continue on to our final example. Okay, so in our final example, what we're going to do is we're going to scan this flights.txt file. Okay, and we're going to follow the same general pattern, open a scanner. We're going to parse the file for the flight info, and then we're going to close the scanner. Okay, so let's go ahead and let's create a new scanner, but this time I'm going to use a constructor which takes in input stream, specifically a file input stream. So this is the way that I typically happen to open up files, is using the file input stream. So I can say file input stream. I'll just call it FIS is equal to new file input stream, and I'm just going to pass in flights.txt, the name of the file. And I'm going to go ahead and import file input stream. And what I want to do now is finally create my scanner. So I'll say scanner. I'm actually just going to use that same file scan up here since I've already closed it. So I'll just say fscan is equal to new scanner, and I'm going to pass in that file input stream. So again, if I hover over scanner here, you'll see that this is the scanner constructor that is taking in an input stream. And you'll see that's the exact same one we used earlier, right? For system.in, it was an input stream. So what we're seeing here is that there's a variety of different types of input streams. The first one we used was the system.in from the console, and now this file input stream is just that, right? It's an input stream that's reading from a file instead of the user console. Okay, so as always, I'm going to go ahead and close this scanner. So fscan.close. All right, so what I want to do now is I want to basically search through this file. But what we're seeing is this file has a number of different lines, and each line has individual pieces of data that we want to pull off. So it doesn't quite make sense like we did with the input text, where we're always just reading words in, and the words on one line kind of went with the words on the next line. You can see here each line is its very own piece of data, so to speak. This is the source and the destination airports, and then this third piece of data is the price itself. So what I like to do in this particular case is I like to read these lines in one line at a time. So I can say while fscan.hasNext line. Okay, then what I can do is I can go ahead and get next line and begin scanning based on CSV, which stands for comma separated value. Okay, basically if you look at each one of these lines over here, I'll pull this down maybe down here so we can see it. Each one of these lines is a comma separated value line. These three specific values are separated by commas. Now this is different from the other file where our values, right, our words were separated by white space. This is a very common way to store data, is these comma separated value files. So we're going to basically show how we can actually reprogram our scanner so that instead of reading word by word, meaning the technical word that's used as a token, each of these words is a token, and tokens are separated by white space, which is the default separating value. What we're going to do is we're going to say now the default separating value is a comma. So everything separated by a comma is actually some important piece of information. Okay, so let's go ahead and grab the line. So I'll say string line is equal to fscan.nextLine. This is going to grab the whole line. So I can go ahead and do like a system.out.print on that line, and if I run this program, -1, you'll see flights.text is the following flights. So you can see at this point that next line is literally grabbing each line one at a time, and so every time I go through this while loop, it says has next line. Yep, I see one. It goes and it pulls it out, and then it goes back for another iteration, says has next line. Yep, pulls it out. Has next line. Yep, pulls it out. Has next line. Nope. And then that's when we end this while loop right here. Okay, so we do have this next line right here. We just demonstrated it by printing it out. So what I actually want to do now is I want to start scanning this line for individual pieces of information. So what I'm going to do is I'm actually going to create a new scanner. I'll call this one lscan for line scan. So scanner lscan is equal to new scanner, and this time I'm going to pass in my line. Okay, so this is the last constructor, scanner constructor that we have not yet seen, which is the scanner that takes in a string as its source. Okay, so now we're going to scan this line, and what I'm going to do is I'm going to reprogram this line scanner a little bit. I'm going to say lscan.useDelimiter, and then I'm going to pass in a pattern. This is a very simple one to start off with, and what I'm going to pass in to start off with is just a comma. Okay, so now what I'm doing is I'm saying, hey, no longer are my tokens separated with white space like we typically want them. Now my tokens are separated by comma. So every time you see a comma, that is the end of a token, right, or the beginning of a token, depending on how you're looking at it. Okay, so now that I've reprogrammed that, I can pull out the three components of the flight. So I can say string source is equal to lscan.next, string dest for destination is equal to lscan.next, and then finally double price is equal to lscan.nextDouble. And finally, let's go ahead and print the results. I should say the formatted results. So I'm going to do a system.out.printf, and I'll just kind of tab it over, and then I'll do %s for the source, and that takes me to %s for the destination, and then in parentheses, do a new line. In parentheses, I'm going to do the price. So I'll do a $, and I'll say %.02f. Okay, and I'll explain that in just a second, but this first parameter is just going to be the source, just printed as is. Second parameter, %s, is the destination, printed as is. The third parameter is the price. So what I did right here is I said, instead of saying %s for the price, I said %f, which basically tells me this is a floating point type of number. It has decimal points. When I put the 0.2, that basically says print out at least 2 digits after the decimal point. Okay, so let's go ahead now and give this a run. So when we play this, say -1, and you see very nicely LAX to Atlanta, $450.99. Dallas to Boston, $204. Ontario to San Francisco, $129.99. Okay, now there's one little thing that I want to show you here. All right, in my flights.txt, I had pretty clean data, right? I had commas. Now, what happens if someone comes in here and says, all right, you know, actually, I want to change this flight a little bit, and let me help me read this a little bit. I added some spaces in there. No longer goes to Ontario. Now it is going to CVG, Covington, Cincinnati, Ohio. And maybe the flight is now $329.99. Okay. When I play this time, right, please enter some data and hit enter. Right, notice what happens. I get 2 pieces of data successfully, but then I get an error, right? And this is actually an exception that's getting generated right here. If we printed the stack trace out, it would show us exactly what's happening. And let me go ahead and do that. I'll say e.print stack trace. Okay, you get an input mismatch exception on line 100, which is this one right here. Okay, why on this line? Okay, what's happening is it looks and it says, all right, well, everything from a comma, like the comma is my separating value. So it says, you know, it gets the line, which is this entire line right here. And then it says, all right, we'll get the first string until I see a comma, right? So what does it do? It grabs O and T. All right. And then it basically just deletes that comma because that's a trash value. Yes, that's the delimiter. So then it says, all right, destination, get the next, right? So, all right, well, cool. That's space CVG, right? And it saves space CVG into a string. And then it trashes the comma. And then the next double, it basically is trying to convert this space 329.99 to a double. And the problem here is this space, right? The space is no longer a delimiter character. It's just another character like the 3 and the G and the V and the C. Okay, so what I would typically do here is add a little bit more to this comma to make it a little bit more flexible. Okay, I want it to be able to ignore these spaces because to me and you, the spaces don't mean anything, right? And someone might actually come and open up this file and manually edit it a little bit just like we did. Okay, so what I want to do is I actually, this string, this pattern is actually a regular expression. So I'm not going to go deep into regular expressions here. But what I can do is I can do a backslash S star. And then the comma, and then the same thing, right? Backslash S star. Okay, essentially what this means is I'm matching. Before I was just matching with a comma, straight up comma. This time I'm matching with any number of white space characters, right? Spaces, followed by a comma, followed by any number of spaces after. And this could be 0 or more spaces. So now when I go ahead and play this, we will see that our program is a little bit more flexible. It works on the cases where there were no spaces, and it also works on the cases where there were a few spaces in there. Okay, so it's just a lot more flexible now. Okay, so the very last thing I want to show you, so we've looked at how to create the scanner constructors that read in the input stream, specifically the file input stream, and as well as the string. The last thing I'll look at is this readable byte channel. So easiest way to show this is on the scanner. We could also, you could say fscan equals new scanner fis.getChannel. Okay, and this get channel just returns the file channel, which if you look at the scanner is a readable byte channel, or it's implementing that readable byte channel. Okay, so let me just run this to demonstrate that that is going to work, and you will see that in fact it is working. All right, so that is the scanner. We took a look at the various constructors. We saw a number of different constructors. Each one has You can see there are 1, 2, 3, 4, 5, 6 different types of sources for the scanner constructor: file, InputStream, path, readable, ReadableByteChannel, and string. And we also saw that each one of those constructors with the various sources also has a second parameter that you can pass in to give it a very specific character data set. That said, this is typically done for you properly and automatically without needing to even include that second parameter. So I usually recommend to just have the source as the only parameter to a scanner, unless you're really doing something with multiple languages on something kind of a little bit more complex. Okay, the number one use case for the scanner is simply scanning the system.in. You can use those has, next, and next methods to really pick out specific primitive data types and strings. The second most important use case is the one in which we are scanning files. And what we saw is basically there's a number of different ways to pass in the source of a file. It doesn't really matter, it's just whatever you feel the most comfortable with for all practical purposes. And the last but not least, do make sure that you close those scanners because that is very, very important. One thing that I didn't explicitly show is if I pass in a bad file name, it should throw an exception for us, which it does. And in that one we're catching, let me go ahead and comment out that stack trace, the print stack trace. So you can see input2.txt, the system cannot find the file specified. So that's why we had to do this whole thing in a try catch, is because anytime that you are opening up a new file, really through any of these various ways that we showed of getting the file into the scanner, all of these will generate checked exceptions. So they basically force us to either surround all this code with a try catch, or of course you can throw the exception out of the main, which is kind of a sloppy thing that you never really want to do. Great. Well, I hope you enjoyed this video, and if you did, please be sure to smash that like button and subscribe to the channel. We've got some really cool stuff coming up.